All right, so as we take a look at both of these, the first question that we got to start thinking about is, when is the velocity increasing? Because if I'm looking to see when it's speeding up, remember that is when the velocity is increasing and the acceleration is also positive. Basically, actually, when I should say rather than increasing, when they both are positive. So when in part A is the velocity positive? Yeah, this one's really tricky because the velocity is positive, actually, basically on the entire graph, from 0 up to, it's kind of hard to tell whether this graph is meant to continue on or not. I'm going to go ahead and say that it just goes ahead and ends at 4, so I'm going to say 0 to 4. Because if I want to know when velocity is positive, notice the graphs below represent velocity graphs. And if this represents velocity, in order to know when velocity is positive, I'm just looking to see when those are positive values. They're above the axis, basically. All right, so then the acceleration being positive. Now remember that acceleration is the derivative of velocity. So if I want to know when the acceleration is positive, that means I want to know when the slope of my velocity graph is positive. This is the one most people are originally thinking of when they look at the graph. Acceleration would be positive from 0 to 1. Because that's where our slope is actually increasing. We're going upward. We have positive slopes there. And with that in mind, it's not the only place where the acceleration is positive. It's also positive where? From 3 to 4. Because again, that's where it switches direction from the negative slopes into the positive slopes. All right, now I want to know those two pieces of information because in order to figure out when it is speeding up when both the velocity and the acceleration are positive. So we can say that it is speeding up. Actually, let's write it down here. Speeding up when those overlap. So they overlap from, well, actually, the velocity is always positive, right? Well, that makes the overlap easy. It's just when the acceleration is positive there. So it's speeding up then from 0 to 1 and 3 to 4. Now that is one way that we figure out when it's speeding up. Remember that we also have another way to know when it's speeding up. It is also speeding up when the velocity is negative and the acceleration is negative. So when both of those are true, I could do that as well. And so, the velocity is negative and the acceleration is negative. Well, when's the velocity negative? Never. Yeah, never. It doesn't happen. And so, we're not going to actually get anything from that. So it is going to be speeding up only on that interval. All right, now for slowing down for part A. Slowing down is going to happen... we can look at it just two different ways. We could just say it's everything where it's not speeding up or 0. Okay, well that would then be between 1 and 3. So it's slowing between 1 and 3. You could also actually go through and then figure out, okay, when is the velocity positive and the acceleration negative and look for the overlaps. Or you could say, when is the acceleration positive and the velocity negative, and look for the overlaps again. All right, now with that in mind, we've seen how we would do it for part A. Go ahead and do the same kind of thing for part B. Figure out when is it speeding up and when is it slowing down. So when doing this problem, so we're on to part B here, I first want to fill in when is my velocity positive, acceleration positive, velocity negative, and acceleration negative there. All right, so let's go ahead and start with that. When is the velocity positive? Remember, the velocity is positive, because this is the velocity graph, wherever it's above the x-axis. So that means the velocity is positive from 0 to 2. The velocity negative, I'll go ahead and jump over to there, since I'm already thinking velocity. The velocity is negative wherever it's below the x-axis. That would be from 2 to 4. Okay, now let's take a look at acceleration. When is acceleration positive? Acceleration is positive wherever the slope of velocity is positive. So that would be from 3 to 4. It's right on this stretch here, because that's where we're actually increasing. All right, and then acceleration is negative wherever it's going down, wherever my velocity is decreasing. So that is going to be from 0 up to 3. All right, now that I know that, I can figure out when is it speeding up, when is it slowing down. So speeding up, that would be the overlap going this way, and it'd be the overlap going this way. It'd be both of those. So from the first one, when they're both positive, where do those two overlap? They don't. Yeah, so they don't at all. So we don't get anything from there. Okay, so let's jump over to this one. Do those at least overlap? Yes. Those at least actually overlap. So we can see it looks like it's between 2 and 3. So that means that this is speeding up between 2 and 3. Notice when it's speeding up, that basically means that it's moving away from the x-axis here. Okay, slowing. When is it slowing down? Well, we could just say everything except that and figure out a way to write that, but just to kind of illustrate, we could be looking to see when is acceleration positive and velocity negative. So it's when do those overlap. And so notice those overlap from 3 to 4. So we're going to have 3 to 4 here. And I can also look to see when the velocity is positive and the acceleration is negative. Again, signs are different. And you can see those overlap between 0 and 2. And so that's how we get it slowing between 0 and 2 and between 3 and 4, which you'll notice also is the same thing, yes, that you get if you just said everything except 2 and 3, because that means 0 up to 2 and 3 up to the 4, since this graph just exists between 0 and 4. All right, so now that you have this problem written down so that you can actually have something to look back at later, let's start taking a look at how we'd kind of proceed through this. We want to know what the maximum height is going to be. Now, to help us visualize, I want to see what would the graph of that look like. So if I sketch the graph of this, seeing that it's a quadratic, and the coefficient of the quadratic term is negative, I know the graph is going to look something like this. It's going to be a parabola opening downward. And if I'm looking for the maximum height, that means I'm trying to figure out where is that point. Now, in order to find that point though, yeah, I could plug it in up here and figure out what S is to figure out that height, but what do I have to plug in order to figure out that S value? T, right? I got to know what T is. So really our goal here is to figure out what is this T value that actually gives me that height. So what is the T value where we reach that point? Where that point should look a little familiar based on work we've recently been doing. This point up here at the top is where our graph changes direction from positive to negative. We've been doing that a lot recently. Well, how have we done that? We've taken the derivative and we set it equal to 0. Because the slope at this point has to be 0. It's flat. So then that's our general course. That's our general plan about how we're going to approach this. All right, so if I'm going to need to find the derivative, let's go ahead and do that first. Let's find the derivative. That's going to be S prime. What does the derivative of S actually represent here? S is a position function. The derivative of position is velocity. Yeah, so I'm going to go ahead and rename that as I go. S prime equals V of t. And go ahead and find that derivative. Should be getting 80 minus 32t for our velocity function, our derivative function. And again, remember why we did that. I want to figure out where the top is here. That is where it's leveling out, so I want to be able to set that equal to 0. So we go 0 equals 80 minus 32t, and then go ahead and solve that equation for t. So when we go to solve this, we end up having to move either the 80 or the 32 to the other side. Then we divide both sides by either 32 or negative 32, depending on which way you did it. And so we end up with 80 divided by 32, which is, as a fraction, 5 halves. Now, since that happens to give me a nice pretty decimal, yes, I can go ahead and give my answer then as a decimal. But I'm going to have to be using this t value here in a moment, and I don't want to introduce rounding error. So if it was a messier fraction, something that didn't give something that's as clean as like 2.5, then I would just leave it as a fraction and do the computations using the fraction instead. But with this case, do it either way. Remember why we found the t value? That tells me that the peak of this graph, the maximum height, is reached at 2.5 seconds. I want to know what the height is, though. It didn't ask me when it happens. It asked me what is the maximum height. So go ahead and plug that t value into your s function, that is the position function, to see what the position will be at 2.5 seconds. And when we do that calculation, the 80 times 2.5 is 200. 16 times 2.5 squared, that gives me 100. So 200 minus 100 gives me an answer of 100 then. Question is, 100 what? Because we do actually have a real situation here. Our units here are feet. Yes, because this is talking distance, so it's just the distance measurement. We shouldn't have per second in there at all. And we're told up here that the 80 was feet per second, so that's how we know it is feet. Right, now the second part that we're going to do today, the other part we're going to be doing today, is we want to know what the velocity of this ball is when it is 96 feet above the ground, both on its way up and on its way down. Take a moment to write down the question, then we'll start working through it. Alright, so in this one, if we're going to try to figure out when it is 96 feet above the ground, basically I'm thinking, okay, there's a line up here at 96, and we're trying to figure out when does it actually cross that. Now you can see from the graph that we'd expect that to happen twice. Now in order to be able to then solve this and know what the velocity is, I need to find out what those two times are. And again, that means I got to solve an equation. And I got to know what the t value is. I need to know what's the time when all this stuff is going down. In this case though, I'm going to start with the position function and then I'm going to go and plug into the velocity function. Because if I'm going to know when it is going to reach a height of 96, that means my position is 96. So I'm going to go 96 equals 80t minus 16t squared. And I'm going to solve that equation now. Notice it's quadratic, so solve it the way we've ended up solving all quadratics. In this case, solving it means, since it's a quadratic, basically we're going to try to factor it. So set it equal to 0, and then see if it's factorable. Now I've just always made a habit out of keeping my quadratic term positive, so I chose to move everything to the left side. You can also do it by moving everything to the right side. Once you have it there, go ahead and factor it. And yes, I'll give you a hint, this one is factorable. Now this one works out nicely factoring because you'll notice that I can actually divide everything through by the quadratic's coefficient, which is 16. And so then I'm just factoring a basic quadratic where I add to -5, multiply to 6, so it gives me minus 2 and minus 3. So therefore t equals 2 and 3. So now I know when that actually happens. I know that it's going to actually reach 96 up there when after 2 seconds and after 3 seconds. Notice one of those represents when it's on its way up, the 2, and one of them represents when it's on its way down, the 3. All right, now notice at this point though, we're not actually done with this problem. Notice what it asked us. It asked us what is the velocity at 2 seconds and 3 seconds then. So I'm going to figure out v of 2. I already know what the velocity function is. That was 80 minus 32t. So I'm going to do 80 minus 32 times 2. So v of 2 ends up giving me 16. And we know our velocity here is measured in feet per second. So that's my velocity when it is on its way up. Positive velocity on the way up. Good sign. They should match. And then v of 3 is the other one. That should be on the way down. So I again plug the 3 in for t in my velocity function. And here you get a negative 16, which again makes sense, I hope. And that again is feet per second. It should make sense because it's symmetrical about the vertex up here. And so the speed on one side should be the speed on the other side, just go in the other direction.